Okay guys, welcome to part 3. I haven't made it clear, and I'm just absolutely sure that you understand. Here is a question where the student doing it has got it wrong, okay? A train covers 27 kilometers in 18 minutes. Find the average speed of the train. So she said, okay, speed equals distance over time. Distance is 27, time is 18. 27 divided by 18 is 1.5. What could possibly be wrong with that? Well, let me tell you something. Trains do not travel at 1.5 kilometers per hour. If they did, you'd be extremely frustrated because you'd get nowhere fast, okay? What this student has done wrong is we've done kilometers divided by minutes and then given our answer in kilometers per hour. It would be true that we're traveling 1.5 kilometers per minute, but we're not traveling 1.5 kilometers per hour. So we need to change 18 minutes into hours. 18 divided by 60 is equal to 0.3 hours. So we should have done 27 divided by 0.3. 27 divided by 0.3 is 90. So we're actually travelling at 90 kilometers per hour, which is a much more realistic speed for a train. You'll actually get somewhere on time if you do that. Okay, so please be careful with your units. Right, now, let's just skip past these. What we also need to be able to do is we need to be able to understand speed, distance and time when we see it in a graph. Okay, so here is a question. This graph shows Zayn's journey to school. Zayn walks to a bus stop, waits for a bus, then gets the bus to school. So this is how far does Zayn travel to school? Well, really, he started at home and then his total distance that he's travelled is 1,600 metres. If we convert that to kilometres, I think it's safe to say he lives 1.6 kilometres from school. Okay? How long does Zayn's journey take? Well, let's just have a look at how much time. The total journey took 10 minutes. Total journey took 10 minutes. How long does Zayn wait for the bus? Well, we've just got to look at where is he stood still. Clearly what's happening here is he's walking to the bus stop. Then he obviously arrives at the bus stop. Then he waits. Okay? And he's clearly waiting for 3 minutes. He's waiting for 3 minutes. Now, at what speed does Zayn walk? Well, speed equals distance over time, but I'm only being asked about the speed that Zayn walks, not the entire journey. So all I really want to know is how far does he travel walking? Well, it seems to me he travels 400 meters and it takes him 5 minutes. But be very, very careful, okay? We're not going to give it in that, you know, that 400 divided by 5. 400 divided by 5 is equal to 80, but the unit measure there would be meters per minute. That'd be a very weird way to give a measure of speed. You always would do it in kilometers per hour, or you would do it in meters per second. Well, it doesn't say which one, so we're going to do kilometers per hour. So what you need to do is change the 400 meters to kilometers. Well, that's 0.4 kilometers. Divided by 5 minutes in hours. So that's 5 divided by 60, which is 1 over 12. Okay, so I need to do 0.4 divided by 1 over 12, which is 4.8 kilometers per hour. That is a very reasonable pace to walk at. 4.8 kilometers per hour. Okay? At what speed does the bus travel? Well, this is the bit of the journey where he's on the bus. So again, how far has he actually travelled on the bus? I would say he's travelled 1,200 kilometers is basically the difference between these two values here. Let's just delete this. So, and let's turn that into kilometers. So 1.2 2 kilometres is how far he's travelled. That's 1,200 metres. In a time of 2 minutes. So 2 divided by 60 is the same as 1 divided by 30. So I'm going to do 1 divided by 30, just change that into a decimal on my calculator. And then 1.2 divided by that answer is equal to 36 kilometres per hour. That is a very reasonable speed for a bus to travel, so I know that I've probably done it right. Okay? So let's have a look at this then. Stop your video and have a go at this. Okay, so all we're doing here is we're trying to describe Jane's journey as best we can. So you just have a look at here, what's going on. She walks at a low speed, stops for a while, and then runs. She runs fast, stops for a while, and then walks. She walks at a low speed and then starts running. She walks at a low speed, stops for a while, and then walks back to where she started. Now, for me, the answer's got to be B. She's walking really, really fast. Now, you may have noticed that actually the speed on the graph is equal to the gradient of that line. Because it's rise over run, isn't it? It's the distance divided by the time. Distance divided by time. So the gradient of the line is actually equal to the speed. Remember, we did work on gradients a few weeks ago. So a higher gradient means a higher speed. So she runs fast, then she stops, obviously gets tired, needs to catch her breath, and then she begins to walk because the gradient is less, so the speed is less. Okay? What about this one? What's happening in this journey? Okay, she walks at a low speed, stops for a while, and then runs. Runs fast, stops for a while, then walks. Walks at a low speed and then starts running. She walks for a while, stops for a while, and then walks back to where she started. For me, that's got to be D. Okay, so she's walking at a certain speed. She stops, maybe admiring the scenery, and then she walks back towards where she started from. So she ends up in exactly the same place. Okay, right, stop your video and have a go at this question here. Okay, Ben cycles to his friend's house 4 kilometres away. He stays there for a while and then returns home. The graph shows Ben's journey. Ben stops at a shop on one of his journeys. Does he do this on his way to his friend or on his way back home? Well, clearly this is where he stays with his friend. This is where he stops in the shop. So he's done that on his journey back. Okay, so it's on his way home. How long does he spend in the shop? That should be easy. He got there after 40 minutes and left after 50, so he must have spent 10 minutes. How long does Ben spend at his friend's house? I think we can read off that he got there after 15 minutes and he left after 35 minutes, so he must have spent 20 minutes at his friend's house. How far away is the shop from Ben's house? Now, I've got to be careful here. How far is it from Ben's house, or how far is it from Ben's friend's house? It's not asking you how far it is from Ben's friend's house. It's asking you how far away it is from his house. So it's here. We can clearly see that's 1.5 kilometres. Okay? Right, again, stop your video and have a go at this. Yasmin runs in a 400-metre race. Her progress is shown on the graph. Okay? How long does Yasmin take to finish the race? Well, clearly the race was 400, so how long did it take her to get to 400? 120 seconds. Okay? How long does she take to complete the first 200 metres? Well, let's just go to 200 metres and let's just read off on the graph. Clearly that took 60 seconds. Okay? How much further did Yasmin run in the first 40 seconds than in the next 40 seconds? So let's have a look how far she ran in the first 40 seconds. She must have run 150 seconds in the first 40 seconds. In the next 40 seconds, that would take us up to 80 seconds. That gets her up to 250. So she must have run 100 in the second 40 seconds and 150 in the first 40 seconds. So it appears that she ran 50 metres further in the first 40 than in the second 40. Okay? Yasmin runs at 3 different speeds during the race. Work out the speeds. Now all you've got to do here to work out the speeds, you can see here, let me use a different colour. This is one speed where I've made it green. Orange, the speed changes because the gradient changes. And then finally the gradient changes again. Okay, all we need to do is work out the gradients of each line. And we can do this in meters per second. That's a very normal way to measure speed. So the first one would be 150 divided by 40. 150 divided by 40 equals 3.75 meters per second. Okay, the second one, we need to know my gradient. Okay, so the rise is going to be 150 and the run is going to be 60. So 150 divided by 60. 150 divided by 60 equals 2.5 meters per second, and that makes sense because the gradient is smaller, so she slowed down, and then she really speeds up at the end. So the run is going to be 20, and the rise is going to be 100. So we're doing 100 divided by 20 equals to 5 meters per second. Okay, there are the answers. Okay, last one. Stop your video and have a go. Okay, the graph shows Tyler running to a shop, spending some time in the store, and then walking home. Okay, bear in mind we've got meters and minutes here, so we've got some pretty nasty units to deal with. How long does Tyler spend in the shop? Okay, well that should be pretty easy. This is where she's in the shop. That's between 2 and 7 minutes, so I'd say that's got to be 5 minutes, isn't it? How far away from his house is the shop? That's pretty easy again. Just read off, it's got to be 500 meters. At what speed does Tyler run to the shop? So the distance is 500 meters. So speed equals 500 meters over 2 minutes. We're never going to do that. We're not going to do it in meters per minute. We'll do it in meters per second. Meters per second. Well, 500 divided by, what's 2 minutes? That's 120 seconds. So 500 divided by 120 is equal to 4.16 recurring meters per second. Now I wonder what they've done here for part C, whether they've done meters per second or whether they've done it in maybe kilometers per hour. Let's have a look. Oh, they did it in meters per second as well. Okay. At what speed does she walk home? Let's just have a look at this gradient. Again, so we're going to look at the rise is going to be 500 again. This time the time is between 7 and 5 minutes. Okay, so 5 minutes is actually 300 seconds. 300 seconds, because there's 60 seconds in a minute. Okay, so speed equals distance over time. Distance is 500 over 300 seconds. 500 divided by 300 equals 1.6 recurring meters per second. Now, the clever of you might have noticed I said that the gradient is equal to the speed. Well, and this one has a negative gradient. So shouldn't the speed be minus 1.6 recurring? Well, technically, but you can't have a negative speed. So what you're really saying is that you're going at a speed of 1.6 recurring meters per second in the wrong direction, in the other direction. So the speed is, you just take the positive value, okay? So there's the answer, meters per second. What what is the total distance covered by Tyler? Now this would be very easy to say 500 because it's 500 metres to the shop. But remember, she goes to the shop and then she returns home. So actually, it's going to be 1,000 metres. She travels 500 metres to the shop and then returns another 500 metres home. Okay? Right, let's leave it there, okay?